All right, guys, we're on to section 9 now, and this is the last section, chapter 8. It's called perfect squares. So before we found the product of a sum and a difference, now we're going to factor perfect square trinomials and solve equations involving perfect squares. And that's our vocab, perfect square trinomial. So let's talk about it. You've learned the patterns for products of binomials, a plus b quantity squared and a minus b quantity squared. We learned that in previous sections. Recall that these are special products that follow specific patterns. So a plus b quantity squared is a plus b times a plus b, which if you FOIL it out becomes a squared plus 2ab plus b squared. A minus b quantity squared is just a minus b times itself. And if you FOIL it out, you get a similar looking thing, except it's subtraction. So a squared minus 2ab plus b squared. So these products are called perfect square trinomials because they are squares of binomials. And the above patterns can help us factor perfect square trinomials. For a trinomial to be factorable as a perfect square, the first and last terms must be perfect squares, and the middle term must be 2 times the square roots of the first and last terms. The trinomial 16x squared plus 24x plus 9 is a perfect square trinomial as illustrated. Notice the first term is the square of 4x. The last term is the square of 3. And the middle term is twice the product of those two. If I do 4x times 3, that would give me 12x. And if I double it, I get 24x. So it fits the pattern. So factoring perfect squares, if I have a squared plus 2ab plus b squared, it factors into a plus b quantity squared. And if I have a squared minus 2ab plus b squared, it factors into a minus b quantity squared. All right, so determine whether each trinomial is a perfect square trinomial. Write yes or no. And if it is a perfect square trinomial, go ahead and factor it. So 4y squared plus 2y plus 9. All right, check the first term. 4y squared can be thought of as 2y squared. Is the last term a perfect square? Yep. And is the middle term twice the product of those two? So 2y times 3 is 6y times 2 is 12y. So yes. So it factors into a perfect square trinomial, and it's 2y plus 3 quantity squared. This one, 9x squared minus 6x plus 4. Is the first term a perfect square? Yep, 9x squared can be thought of as 3x quantity squared. Last term, 4 is the same as 2 squared. Is the middle term equal to twice the product of those two? Well, if I do 3x times 2, that would be 6x. Double it, you get 12x. While this is not negative 12, it's negative 6. So this is not a perfect square trinomial, so I don't have to try to factor it. It said only factor it if it's perfect square. All right, here's 2 for you to try. Go ahead and pause the video. Okay, we're back. So first one, 1a, the first term is 3y quantity squared. We're good. The last term is 4 squared. Good. Now if I double 3y times 4, that gives me 24y. Yep. So this factors into 3y plus 4 quantity squared. Okay. 1b is 2a squared. Well, I can't write that as something squared. Can't do it. So no, it is not a perfect square trinomial. Okay, even though the last term can be thought of as 5 squared. First term you can't write as something squared. All right, a polynomial is completely factored when it is written as the product of prime polynomials. More than one method might be needed to factor a polynomial completely. When completely factoring a polynomial, the concept summary can help you decide where to start. Remember, if the polynomial does not fit any pattern or cannot be factored, the polynomial is said to be prime. So factor out a GCF is a greatest common factor of all the terms. You can check to see if there is a difference of squares or if it's a perfect square trinomial. You could also apply factoring patterns for x squared plus bx plus c or ax squared plus bx plus c, or factor by grouping. And usually if you do factor by grouping, there's usually going to be 4 terms. Okay, so those are the options that you have. All right, so example 2, let's factor each polynomial if it's possible. And if the polynomial cannot be factored, we're going to write prime. So 5x squared minus 80. First, you could factor out the GCF of 5. So take out the 5. And there are 2 terms we got to check for difference of squares. So take out a 5, you get x squared minus 16. So that is a difference of squares. And factor it as x minus 4x plus 4. Don't forget your factor of 5 in the front. And then if you check the other factors, there's nothing else to factor out of here. Okay? So this one, you have 3 terms. So it's a trinomial. So first thing, we always check to see if there's a GCF, since the only factor of all 3 of those is 1. There's nothing really to factor out. You don't really ever factor out a 1 very much. 35 is not a perfect square, so it's not a perfect square trinomial. So then we're going to factor using the pattern ax squared plus bx plus c. So we look for the product of negative 35 and 9, so which is negative 315. And then we look for factors of negative 315 that add up to negative 6. So that would be 15 and negative 21. So I would do 9x squared plus 15x minus 21x minus 35. And then factor those by grouping. The whole reason we did the product of 9 and negative 35 is to get the factors that you break apart the middle terms so that you can do the factor by grouping. So these 2 you could factor out of 3x and get 3x plus 5. And these 2 you could factor out a negative 7, so you would get 3x plus 5. And then they both have a factor of 3x plus 5, so you have 3x minus 7 times 3x plus 5. Okay? Pretty cool there. I did that because I wanted to show you all of the work for that. Okay? And there's the steps for our answer. All right, here's 2 for you to try. Go ahead and pause the video. All right, we're back. So 2a, I can factor out a 2, so that becomes x squared minus 16, which is a difference of squares, so it becomes 2 times x plus 4 times x minus 4. And even though 4 is a perfect square, x is not a perfect square, so this is not difference of squares, so that's all the further we can go. 2b. All right, the only number that divides evenly into all 3 terms is 1. While 25 is a perfect square, 12 is not, so this is not a perfect square trinomial. So we multiply negative 12 and 25 and get negative 300. So we're looking for factors of negative 300 that add up to 5. Okay. So since the number is negative, I'm going to have 1 positive factor and 1 negative factor. And since the sum has to be positive 5, I know that the bigger factor has to be positive. So I could do 20 and 15, and the 15 would have to be negative. Okay? So I got that pretty quick because I kind of knew what the answer had to be. You know, you might have to go through several factors of 300 in order to get it. Okay? So that's going to break the 12x squared up into 12x squared plus 20x minus 15x minus 25. Group the first 2, I could take out a 4x and get 3x plus 5, and then factor out a minus 5 from that one and get 3x plus 5 here. And then it's 4x minus 5 times 3x plus 5 there. Okay, and that's our answer. Okie doke. All right. So that's it for this video. Please stay tuned for the second half.